Welcome to APA's weekly webinar. My name is Billy Zadig, Standards and Codes Administrator for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to APA's website later this afternoon, and a follow-up email will be issued to you as a reference on where to locate the session. Professional continuing education and AIA HSWCLU credits are being offered for today's program. If you are an AIA professional requiring a certificate, please send an email to me at Billie, B-I-L-L-I-E, @apa.org, along with your AIA membership number if you have not done so in the past. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by the presenter. At this time, it's my pleasure to turn this over to Bill Koffel of Koffel Associates. Bill, take it away.
Thank you, Billy. And good morning, good afternoon, depending upon where you are. And welcome to this Koffel Talk, what you need to know about NFPA 13 and NFPA 25. This is actually one of two that I will be doing. Next month, I'll be doing one on NFPA 101. As you probably know, we had hoped to do these at APA's conference, but because of the pandemic, we've had to cancel that conference, and therefore we're doing these as virtual presentations. So just as some introductory information, since this program has been approved for AIA continuing education credit, upon completion of the course, your participation will be reported to AIA, and the certificates of completion for both AIA members and non-members are available upon request. And again, that's the type of thing that you can email Billy about. A little bit about my background. I am president of Koffel Associates. We're a fire protection engineering and code consulting firm headquartered in Columbia, Maryland. In the past, we have provided some code consulting services to APA. But as it relates to our program today, I've served on a number of NFPA technical committees. I am the immediate past chair of the NFPA 25 technical committee. I currently chair the correlating committee for NFPA 13. That's the committee that oversees all of the technical committees that have responsibility for various portions of NFPA 13. And while we won't be talking about NFPA 72 today, I know a topic of interest to many of you is the emergency communication systems. That chapter 24 in NFPA 72 also includes mass notification systems, and I am the chair of that committee as well. Overall, I have over 40 years of experience in the industry with being a volunteer firefighter, being with the Maryland State Fire Marshal's Office, and then since then being in the consulting industry. So a basic description of what we hope to accomplish today is that I'll provide an overview of the two documents, NFPA 13 and NFPA 25, and I'm focusing on how they impact you, facility personnel at higher education facilities. If you happen to be a design professional, I believe you will also be gaining knowledge, information, in particular about NFPA 13 and higher education facilities. Learning objectives, and we have quite a few since we're talking about two different standards. Upon completion of this program, you should learn how to appropriately evaluate sprinklers. What are the appropriate sprinklers to be used for different parts of your facility? What are the minimum requirements for the usage of sprinklers? And what are the proper installation requirements? And we are not going to have time in this 90-minute segment to go through all of those requirements. I will be giving you an overview and discussing how NFPA 13 treats those issues and when you would potentially need to go to NFPA 13 to find the answers to those questions. You'll also learn the difference between NFPA 13 and NFPA 13R, since some of your dormitory facilities, you might be using NFPA 13R sprinkler systems. With respect to NFPA 25, you'll understand the actions that must be taken whenever there's a change in occupancy, use, a process, the materials being used, the hazard classification, or the water supply that might affect the overall performance of your water-based fire protection system. You also learn about some changes that have been made to both NFPA 13 and NFPA 25 since they were last published, or I guess I should say, since the additions that you are most likely using. So most jurisdictions do not adopt NFPA 13 or NFPA 25 directly. There are some states that do. We usually get to those documents through a building code, a fire code, a life safety code. So most of you are going to be operating under, for NFPA 13, either the 2013 or 2016 edition. So I'm going to talk about some of the things that are in the 2019 edition, just so you know what may be coming if your jurisdiction adopts a newer edition. And then the same thing with NFPA 25. You are probably in a jurisdiction that is using the 2014 or 2017 editions of those documents, and I'll identify some of the things that are in the 2020 edition of those documents. And then kind of going back to, I tried to correct a typo on this and I did it incorrectly. Learn the difference between installing sprinkler systems in accordance with NFPA 13 and 13D. So above we talked about 13 and 13R, then we'll talk about 13 and 13D. So what is the scope of NFPA 13? So many of you as facility managers will not be using NFPA 13 that much unless you're going to answer a specific question, maybe during a rehab project. The use of NFPA 13 is typically going to be by the design professional and the contractor who is installing the system, because NFPA 13 provides the minimum requirements for the design and the installation of automatic sprinkler systems, with the purpose of those requirements being to provide a reasonable degree of protection from life and property from fire. And I just want to focus on that for a moment, because many people look at sprinkler systems as a property protection feature in the building. And that comes from the old insurance perspective and the buildings that we used to install sprinkler systems, and the industrial occupancies, the highly protected risks, the warehouses, storage occupancies, and so forth. But today, as required by most building codes, you are probably putting sprinkler systems in almost, if not every building that you build and or rehab on your campus. And that is in part due to the fact that there has been identified, with some changes in sprinkler technology, a life safety benefit to installing sprinkler systems. And this first found its way into the codes back in 1991, when the Life Safety Code put in a mandate that all new sprinkler systems in healthcare occupancies needed to be what was called a quick response sprinkler, a type of fast response sprinkler. Now, prior to that, in residential occupancies, there clearly was the use of residential sprinklers, which is another type of fast response sprinklers. The advantage of the fast response sprinkler is that it operates more quickly, and it's not due to temperature rating, because I can get an intermediate temperature fast response sprinkler. It's due to the operating element itself. It will respond to that increase in heat more quickly than a standard response sprinkler will. And we have shown by fire tests and computer modeling that in residential occupancies, like your dorm rooms, in the patient sleeping room of a hospital, we can maintain tenability at the bed level from most fires in those types of occupancy. So there's the life safety benefit. And the fact that we're providing a life safety benefit obviously also then enhances the property protection. So let's talk a little bit about some of the design criteria. The way NFPA 13 operates is we have a series of boxes And these are different than the boxes that you'll see in a building code or the life safety code, where you'll see references to low hazard, moderate hazard, and high hazard, because those tend to deal with the life safety threat of the fire. In the case of NFPA 13, we are dealing with the challenge the fire will present to the sprinkler system. And these hazard classifications affect things like the duration of your water supply, the density that needs to be delivered to control the fire, so the overall quantity of water that you need for the sprinkler system. It will affect the spacing of the sprinklers. In some cases, it actually affects whether you can use a certain type of sprinkler or whether you may be required to use a certain type of sprinkler. Now, for other than storage occupancies, NFPA 13 identifies 5 different hazard classifications. Many of your facilities, the spaces within those facilities are going to be what's considered a light hazard. We have a low quantity of combustibles, relatively low heat release rates. We don't quantify what those rates are, but they're low as compared to some more severe fire scenarios that I might have with ordinary or extra hazard. And we specifically identify in the annex of NFPA 13 that things like sleeping rooms, office space, seating areas and assembly occupancies, those are all examples of a light hazard occupancy. So in your mind, if you envision the fuel package that you might have in a residential or dorm sleeping room or a classroom environment, or again, the seating area of an assembly occupancy, that's what we mean by that relatively low quantity of combustibles and that relatively low heat release rate. Now, even within this building, let's assume this building is mostly classroom or office space, even within this building, there may be some other areas that would be classified as ordinary hazard or extra hazard. So the ordinary hazard spaces that you are likely to find on a campus, you see in the upper left-hand corner a slide of a restaurant. Again, I already said the seating area is light hazard, but the cooking facilities, the kitchen area, where there's a higher concentration of fuel, would be ordinary hazard. Your bookstore, the mercantile, retail type locations on your campus are going to be ordinary hazard. So those are just 2 examples of spaces that would be classified as ordinary hazard. Extra hazard, we tend to get into areas where we're likely to encounter combustible dust or quantities of flammable and combustible liquids. So again, some of your lab spaces or research areas might fall into the extra hazard classification. But I suspect most areas on your campus are going to be light hazard or ordinary hazard. So how does that affect you as a facility person? When somebody comes in and says, I want to change this office to some other use, one of the things that needs to be evaluated, and you might not be doing any construction, so you might not be pulling a building permit for this, one of the things that needs to be considered is, are we changing the occupancy, the hazard associated with that space? So that's the reason for going through this generic discussion. I'm not going to go through storage. There's a whole different way we deal with storage, and it's called commodity classifications. And it's based upon the commodity that's being stored, how combustible that commodity is. So with storage, if I take that example and somebody says, well, I want to take this office and I want to convert it to a storage room, we now need to go look at storage requirements for that space. And we define something called a miscellaneous storage occupancy, something that's incidental to the primary use of the building, like maybe that small office might be, that would be miscellaneous storage. We have to evaluate whether the current sprinkler design and spacing is adequate for that new use, that new hazard. We'll talk a little bit more about that when we get to NFPA 25. Now, another thing that NFPA 25 addresses is what types of sprinklers may I use, or what types of sprinklers must I use in some cases in certain spaces. So going back to my light hazard occupancy, NFPA 13 now requires all new systems in a light hazard occupancy need to use fast response sprinklers. And I emphasize the word new. If you are rehabbing an existing light hazard space and it's still staying as light hazard, and it is protected with standard response sprinklers, then that would be acceptable. You can continue to use the standard response sprinklers. But if it's not a sprinklered space and you're putting sprinklers in, NFPA 13 will tell you that you need to use a fast response sprinkler. Now, it's not necessarily easy to see on this photo, but you do see a relatively small glass bulb. If you look around some of the buildings on campus, you may see glass bulbs that are close to about 3/8 of an inch in diameter. That sprinkler is going to be a standard response sprinkler. When we get down to a 5 mm glass bulb, that could be a fast response sprinkler. At the 3 mm bulb, it probably is a fast response. The way I know is by the listing of the sprinkler. And for quite a while now, NFPA 13 has required something called a sprinkler identification, SIN number. It would be on this sprinkler, it'd be on the top of that deflector. And I can punch in that sprinkler identification number, even if I don't know the manufacturer, although part of this sprinkler identification number should tell you the manufacturer. That's an alphanumeric characters, the first two characters, like VK would tell me this sprinkler is Viking. So I might see VK, and then I'll see a series of 3 or 4 numbers. Those 3 or 4 numbers, I can punch that in on the Viking website, or I can just go to a browser and I can punch in VK102, and it will tell me what the characteristics of that sprinkler are. It will tell me whether it's standard response or fast response. It will tell me whether it's an upright sprinkler like we see here, or a pendant sprinkler that should be below the pipe, or a sidewall sprinkler. So it'll tell me the orientation of the sprinkler. And there's other characteristics that it will tell me as well. But again, those are all important performance characteristics. You don't want to have an upright sprinkler like we see here, and you decide to lay an acoustical tile, and you now take that upright sprinkler and you simply rotate that elbow 180 degrees, and that sprinkler now is in a pendant position, because that sprinkler is going to cause that water to go up towards the ceiling if you do that. Other installation requirements, and again, we could spend a couple of hours on these. I just want to go through the types of things that are covered by NFPA 13. So depending upon the type of sprinkler you have and the hazard that's being protected, NFPA 13 will establish the protection area, that this sprinkler is able to protect an area of 100 square feet or 130 square feet or 225 square feet. Those are common numbers that you will find in the standard. So again, if I go back to that office, if that office happened to be 200 square feet and it had a single sprinkler in it, and I'm now converting it to a storage use where now my spacing might need to be 130 square foot per sprinkler, I may need to add another sprinkler in that space. Sprinkler spacing talks about how far the sprinkler may be away from the wall. And in most sprinkler types, there is a maximum distance, there is a minimum distance. There is also a minimum distance between most types of sprinklers. You know, one of the things that I see sometimes is I'll walk through a building and I'll see a sprinkler very close to a wall. And out of curiosity, I'll immediately go to the other side of the wall and I see the sprinkler on the other side is some significant distance from the wall. And they don't have to be equal distance, but it's a much longer distance. And I'll ask the facility, is this wall relatively new? And they tell me, yeah, we installed this wall, but they did not move the sprinklers so that they could meet the sprinkler spacing requirements. And while the sprinkler close to the wall might be far enough away, because we do allow sprinklers to be, typically it's 4 inches from within 4 inches, at least minimum distance from the wall is 4 inches. Let me say it that way. But on the other side, the sprinkler's too far from the wall. And, you know, logically, if you think about this, the sprinkler's going to discharge water in a circular pattern. So these spacing requirements are really just to try to ensure that we are wetting most of the areas of the space. Under obstructions, I'll make a comment as to why I use the word most in that last sentence. Deflector position is how far beneath the ceiling may the deflector be. I won't reveal the educational facility, but in an engineering building, at this particular facility, I was in the facility and they had removed the lay and acoustical tile ceiling. They did not reposition the sprinkler. The sprinkler was too far beneath the ceiling. Now, somebody made the decision to put a square metal pan above the sprinkler, thinking that that would be a heat collector. Doesn't work unless you can tell me the sprinkler is going to be directly underneath that sprinkler. What happens in the fire is the plume goes up to the ceiling. We develop a ceiling jet and a hot layer in the top of the room. So unless the fire plume is underneath that metal pan, the hot gases are still going to go to the ceiling, and that means we're going to have a delayed time to operation of the sprinkler. There are a variety of obstruction rules with the basic intent that we have to get water to the other side of this obstruction. For example, a steel I-beam can be an obstruction. A bar joist can be an obstruction. We can have floor-mounted obstructions, such as partial height partitions in an office area where I need to get the water over top of the obstruction. Again, with the intent that I need to wet most of the area. There is language in newer editions of NFPA 13 that does say you do not have to wet 100% of the area. I could have a small corner of a room that I don't quite have adequate coverage. If we have a fire in that corner, it's not going anywhere. We're still going to control that fire because we're wetting everything around that space. So unless you have a keen interest in trying to quickly suppress the fire in what's in the corner of that room, it really should not be a problem. In addition to obstructions, we need to get the water over top of the storage. The number you will typically hear is 18 inches. That is a horizontal plane beneath the deflector of the sprinkler. I emphasize that because back in earlier years of my career, when I was with the State Fire Marshal's office, I told a facility that they need to keep the storage 18 inches away from the sprinkler. And they took me to my word. They created a hemisphere with a radius of 18 inches. And 20 inches away from that sprinkler, stuff was stored up to the ceiling. Again, think of an umbrella distribution pattern, and you need to get the water distributed over the area that that sprinkler is intended to protect, which takes us back to the second bullet, the protection area per sprinkler. There are also special provisions, depending upon the sprinkler type, that will deal with things like ceiling pockets and skylights. And do you need to put a sprinkler up in those spaces, or are those spaces small enough that don't require a sprinkler in that space? The last thing I want to talk about with NFPA 13 is that NFPA 13 and the codes that reference NFPA 13 operate under the premise that sprinklers will be everywhere in your building, unless NFPA 13 provides language that says sprinklers are not required in certain spaces. So on the slide, we see a non-combustible concealed space. Steel building, lay an acoustical tile or gypsum wallboard or something as a ceiling membrane. Yes, you may have some data cable up there. You may have some power conductors up there, but there's not enough up there that's going to cause the fire to spread throughout that space. We don't need to put sprinklers in that space. Now, when I have combustible construction, the answer to that question is far more challenging, because there are some concealed combustible spaces that I need not have sprinklers, according to NFPA 13. There are others that, to meet the requirements of NFPA 13, we would need to provide sprinklers in those spaces. And again, it would probably take about 30, 40 minutes just to go through those requirements related to combustible concealed spaces. If I discount the 2019 edition of NFPA 13, and I go to the ones I mentioned earlier, 2013, 2016, you'll find these provisions in 8.15 of the standard. Now, one of the differences between NFPA 13 and NFPA 13R and NFPA 13D is, in fact, those concealed combustible spaces. So NFPA 13 has a broader scope looking at property protection. Therefore, as I said, we generally expect to see sprinklers in most of those concealed combustible spaces. What we learned in the mid-70s was that many of our fire deaths were occurring in low numbers in residential dwellings. Therefore, in an attempt to reduce the cost of provide sprinklers in dwelling units, like maybe the president's house on campus, NFPA developed the standard NFPA 13D. It reduces the water supply. For a residential occupancy under NFPA 13, you need 30 minutes of water. For 13D, you need 10 minutes of water. If I'm using residential sprinklers in NFPA 13, I calculate 4 sprinklers flowing. In 13D, I typically calculate 2 sprinklers flowing. And 13D allows me to omit sprinklers from concealed combustible spaces, because the fatal fires tend not to occur in those spaces, but rather they tend to occur in the sleeping room, the living room, the kitchen. Those spaces we would be providing sprinkler protection. Now, what we saw as people started to become accustomed to 13D is that 13D systems were going in multifamily residences, like your dorms or multifamily apartment buildings. And it really wasn't designed for that. It was set up for single family dwellings. So NFPA came out with a third standard around 1985 for low-rise residential occupancy. This is generally limited to a 4-story building, ties into fire department access, because again, 13R does not require things like a concealed combustible attic space to be provided with sprinkler protection. So we don't want this in a high-rise building where a fire in that attic space would present a significant challenge to the fire department. But other than that, 13R more closely approximates NFPA 13. Again, I will typically calculate 4 sprinklers. It's a 30-minute water supply. But again, I do not have to have sprinklers in those concealed combustible spaces. So you may see some dorms on campus, in low-rise dorms, where you might be using a 13R system. Now, there are other special situations. I don't want you to leave this program thinking that the only ones are concealed combustible spaces. If you're being confronted with a question, do I need to put sprinklers in an electrical equipment room? And somebody's arguing, oh, well, electricity and water doesn't mix. NFPA 13 answers that question. And the answer is maybe, or it depends. And it depends upon the type of electrical equipment. Do you have fuel-fired equipment, or not fuel-fired? Do you have liquid transformers in there? Do you store combustibles in the space? What's the separation between the electrical equipment room and other spaces? That will all dictate whether I need to put a sprinkler in that space. If you are concerned about that sprinkler discharging on the electrical equipment, then I want to look at a different type of sprinkler system, like a pre-action system, in which somebody hitting the sprinkler, we will not get accidental water discharge out of a pre-action system, because I also have to have detectors in that space that would detect the fire before we discharge water. Other things that I see on college campuses would be the protection of escalator openings, or maybe even larger openings. In a lot of the student union buildings, I'll see these large vertical openings that the building codes call an atrium. So do I need to have sprinklers around that space? Do I need to closely space sprinklers around that space? Do I need to have, it's a little hard to pick up in that photo, but there is a clear draft curtain around that space designed to prevent the smoke from going up through that vertical opening until the sprinklers can operate and control the fire and cool that smoke. Therefore, the smoke would be less buoyant. So that basically gets us through the types of things I wanted to cover in NFPA 13. I said I wanted to spend a little bit more time on NFPA 25 because as facility personnel, you are probably going to deal with NFPA 25 more than you deal with NFPA 13. NFPA 25 is where I go to define the inspection, test, and maintenance requirements for all water-based fire protection systems. So the sprinkler system, the standpipe system, the fire pumps you may have, tanks if you have them, the inspection, test, and maintenance requirements are found in NFPA 25. Now, some people will argue that NFPA 25 is a wear and tear document. In other words, it doesn't really do much for me except tell me whether there's been some deterioration of my system, that my sprinklers are corroded or loaded or have paint on them or whatever the case might be. I don't buy into that concept. I will share with you, and you'll hear me talk about this again a little bit later, that the inspectors or the individuals that are required to do the inspection activity do not need to evaluate the design and installation requirements. So in that sense, yes, the inspection activity is more of a wear and tear activity, but the owner still has the responsibility to make sure that the system is adequate for the hazard being protected. And again, in new construction or rehab work, I would expect that that the design team would take care of that for us. The oversight by the regulatory agencies would take care of that for us. So as facility managers, you get involved when we start making changes within those existing buildings. There was a research foundation workshop back in December 2013. I just want to talk about a couple of things that came out of that research foundation, because one of the things we were trying to address as a technical committee is how do we improve the reliability of our sprinkler systems? It is good today, but it could be better. And is it that NFPA 25 needs some revision? Is it an enforcement issue? Is it an application issue? So this foundation workshop looked at those issues, and we're going to talk a little bit about what we learned during that foundation workshop. So again, the inspection activity is going to identify things like corrosion. Here we see in the lower photographs, we're doing an internal tank inspection, and we can look at the condition of the tank. And do I have silt or something accumulating in the tank that once I start flowing water through that pipe, we're going to get that into our sprinkler system. And yes, it may go through that 6-inch pipe, but it may not make its way through that 1-inch pipe that we have going to that sprinkler. Design evaluation. So I struggle with this as a member of the NFPA 25 committee, because we're going to tell you that that is the responsibility of the owner. Most owners, remember, we're putting sprinkler systems in most buildings that are being built today, low-rise office buildings, etc. Most owners don't have that expertise to know, and we spent a couple minutes talking about occupancy hazard. Most owners don't know that. Most owners don't know whether I need to have sprinklers in that concealed combustible space that I see in the lower right-hand corner. Most owners aren't going to know that NFPA 13 has spacing requirements to keep sprinklers away from heat-producing equipment. I mean, I was involved in a litigation case where a yoga studio, which had sprinklers in it, was converted to a Bikram yoga studio. And the sprinkler was too close to that unit heater, and the sprinkler activated, causing a fair amount of water damage. But 25 is going to put that responsibility on the owner or the owner's representative. If you hire a contractor to do the inspection, test, and maintenance on your system, they most likely are not doing that. And whenever I am involved in a litigation case where there are design or installation problems with the system, the typical defense of the contractor providing the ITM services, that's outside our scope. Look at Chapter 1, NFPA 25, says we don't have to verify the design and the installation. Now, the other side of the coin is the cost would be phenomenal if you required a contractor to go in there once a year and reevaluate your system. And that's why I have focused on changes. If we can assume that the system was properly installed initially, then we can really focus on what changes might occur to the building post-initial occupancy that might cause the need for a reevaluation. And on the non-storage side, this can be relatively obvious. I tried to cover a number of them. On the storage side, it's not as obvious. I was teaching an NFPA 13 seminar, and I had a person with the cosmetic industry, and we were talking about commodity classes. And at the end of the discussion, she raised her hand and she said, so you're telling me the fact that we now put our product in plastic containers as compared to glass containers, that our sprinkler system may not be adequate to protect the hazard? And the answer is yes. That's what I'm saying. Think about everything that is plastic today that wasn't plastic 20 years ago. If you had a system installed assuming that those were non-combustible materials, and now you have plastic materials in there, that's a problem. We have a new problem, and the committee's still trying to struggle with this. And I'll call it the Amazon problem. You know, Amazon delivers packages and leaves them on the outside of our building. That has caused them to use a cardboard container that is more water resistant. That more water resistant container doesn't allow my sprinkler water to seep through the container, and therefore we're going to get a different fire than what we have in the older cardboard containers. And we're looking at, does that require some different design criteria for the sprinkler system in that space? I don't think most owners are going to realize that. We're going to come back and talk about, well, who's going to do it if the contractor's not doing it and the owner may not have the expertise to do it? So that container is a management of change issue. If you have warehouse space and you're storing something different in that space today, somebody needs to look at that sprinkler system. If you are using encapsulated storage, where I now wrap the product on that pallet load in plastic, that changes my sprinkler design criteria. So there's a lot of things that can change in a storage occupancy. What might appear to be a very subtle change that could require a reevaluation of the sprinkler system. And while permitting is an answer for many of the situations, some of the things I just talked about, changing containers, changing the commodity that you're storing in the warehouse, you most likely are not getting a building permit for that. So there is no regulatory agency that's overlooking that. If the spacing that I see here for these sprinklers was caused by some new construction activity, yes, I would expect that the building permit that you got for that construction activity would have identified that the sprinkler in the lower right-hand corner is too close and the sprinkler in the upper left-hand corner is too far away from the wall that we see. So during this workshop, we heard from the different interested parties or stakeholders. And the insurance industry, they said, we have reduced resources. We're not doing evaluations of buildings like we used to. And they also told us that primary failure modes of the sprinkler systems are frozen systems, accidental discharge claims, corrosion, impairments of the system. They kind of focused on fire pumps, but I'm going to refer to impairments generally because that also kicks in closed valves. 2/3 of the fire incidents where a sprinkler system fails to control the fire, the cause or the reason the system did not control the fire is the valve was closed or mostly closed. And I don't really have time to go into, well, I'll tell you one story, but there's multiple cases that I could identify where we had a loss that was other than what was normally expected. So a number of years, I was sitting in my office in Columbia, Maryland, and an attorney called me up and said, I have a fire investigator in this warehouse fire that occurred last night in this fully sprinkled warehouse on the south side of Baltimore. And he said, the investigator thinks that the sprinkler valve is closed. I need you to go out and take a look at it, which I did. And yes, the valve was closed. And I came back and I called the attorney and I said, yes, the valve is closed. And my preliminary research indicates that Baltimore City Fire Department did not close that valve during their suppression activity. So most of the time, if it's a fire, the fire department's not going to do that. So the attorney came back to me and said, oh, that's good news. I said, well, why is that good news? He said, well, we had a roof. So we're working for the owner of this warehouse. We had a roofing contractor in here, and they did some roofing work. And in order to do the roof work, they had to remove the sprinkler system. And I'm assuming that caused them to shut the sprinkler system. I said, yes, it probably did. If I removed the sprinkler system, I closed the valve. And I said, well, where was this work done? And he told me. And I said, well, yes, that's the valve that I found closed, and that's the area where this fire started. And I said, but I have a question. When was this work done? And he said, 4 years ago. And I said, you understand that's not good news? They said, well, why not? I mean, he was looking to subrogate this and sue the roofing contractor. I said, because NFPA 25 requires a monthly inspection of the valve to verify that it's in a fully open position. This valve was electrically supervised, but it had been closed. I said, how do I explain that, one, we ignored any supervisory signal when the valve was first closed 4 years ago, and secondly, that we did 48 inspections and failed to identify that that valve was closed? And he said, I'll get back to you, which he did. He got back to me a little later and said, you will not be hearing from me. I tend to do plaintiff work to this insurance carrier. You have convinced us that we are going to be a defendant, that the tenants that had property in that warehouse are going to be suing us. And therefore, this will be turned over to a different law firm that deals with defense litigation for the insurance carrier. But that issue's far more common than it should be, especially with that monthly inspection activity. Again, many of you have a contractor that may come in and do certain inspection, test, and maintenance activities. You most likely do not have the contractor coming in on a monthly basis. So there's an inspection activity that somebody else needs to be performing. And on larger campuses, a lot of times there's a fire marshal or safety department or somebody that would be doing that. Don't necessarily think that the insurance carrier is going to be coming in there, certainly not on a monthly basis, checking that valve. So what the insurance carriers told us is there's things that need to be addressed, and some of these might be outside the scope of NFPA 25, in particular when it comes to design and installation issues. Some of us try to educate our clients, but we can only go so far, and they may only give us a certain amount of time to do that. And they also recommended that any recommendations that a contractor does make with regard to design and installation should be sent on to the insurance carrier, because then they can follow up on it, or to the authority having jurisdiction. So I had another fire involving, in this case, it wasn't a closed valve, but it was a design issue. It was a health club, and we did not have sprinklers in the sauna portion of the health club. Allegedly, according to the designer of the system, left out because the owner told them to leave them out. The owner denies that. It was not picked up during the permitting process. The system went in without sprinklers in the two saunas. The fire occurred in one of those, and the fire overran the sprinkler system, and the owner had a loss greater than what they would have expected. Now, the contractor who did the inspection activity said, not my job, outside my scope, that's a design issue. However, this person actually owned a couple of health clubs, and during the litigation, it was noted that the contractor actually did provide recommendations or comments on design issues in other buildings. So the court found in favor of the owner, saying the contractor was providing a different level of service in some of these buildings, and felt that the contractor probably should have at least called to the attention of the owner. You know, as the inspecting contractor, I might not know that it's a violation. Maybe somebody got a variance from the local jurisdiction or something, but at least make a comment, an observation, that we observed there was no sprinkler in the sauna. And here's the last piece in this particular case that was damaging, because the fire marshal, the same person who approved the plans without the sprinklers in the sauna, stated in his deposition, well, if the contractor had put that note on an inspection report, I would have gone into the building and told them that they had to put sprinklers in the sauna. You kind of see where the contractor came out on the losing end of this, which was fully expected because a similar case had already gone to the Supreme Court in New Jersey, and they ruled that we don't really care what 25 says. Contractor's the expert. You should have alerted the owner. But that's New Jersey. Again, NFPA 25 doesn't require that. I already mentioned that insurance carriers tend to have limited resources. We had a panel discussion that also included a contractor representative, an owner representative, a fire official, and then another contractor who on the 25 committee actually represents a certain user group. So I kind of put him as a different entity. And, you know, they all said that this needs to get done, but the question is by whom? And the fire official said, we don't have the resources to do these evaluations. So the message I'm delivering to you is, when it comes to design issues for your system, in particular for any changes that get made to your system, do not necessarily expect the inspecting contractor to verify that it's okay. Do not necessarily expect a fire marshal who might be doing an inspection. Again, I know campuses have their own fire marshal. It might be a little different on campus, but generally speaking, don't expect the fire marshal to do it. And I've already said I don't expect the owner to have this understanding of the design of the system. Again, I tried to highlight you on some of those. So the group could not reach any consensus as to whether contractors should provide observations or recommendations. I will tell you that an attorney that participated in this workshop and for whom I've done some litigation work, he will tell his contractor clients, do not go beyond the scope of 25. The moment you do, just like that contractor in NFPA in that fire in New Jersey, you will be potentially cited for providing a different standard of care in different buildings. Stick to the scope of NFPA 25. That's problematic for those of us that own buildings. I know there was one contractor I could not believe. He publicly stated this. He said, when I'm bidding a new project, I will give the potential client two different proposals. One is what's required by NFPA 25, and one is what's required to satisfy the fire marshal in that jurisdiction. And his comment was, if I don't give that second quote, I won't get the project because other contractors are out there doing it that way. So do we need to have some type of reevaluation of a system at a period of time? You know, some of the codes that talked about this, there's no specific requirement that says every 5 years, 10 years, somebody needs to go in and reevaluate the design and installation of the system. Right now, we kind of leave it up to the owner to manage change, identify when changes are made and how that they might have an impact on the system. And you may not know the requirements well enough, but call somebody in, contractor, consultant, engineer, maybe even the fire marshal for a specific focused visit and say, is my system going to be adequate if we make this change? We did recommend, however, that, and when a contractor goes in for an inspection activity, it probably would be worth asking the building owner some questions like, did you make any changes in your building in the last year or since I've been here last time? Okay, enough on the owner's response on that discussion. Let's now look at some of the requirements in NFPA 25. You will find a chapter for each type of sprinkler or for each type of water-based system. So there'll be a chapter 5 on sprinkler systems, chapter 6 on standpipe systems, chapter 8 on fire pumps, and so forth. At the beginning of each of those chapters, there will be a summary table of what all the tasks are, what are the inspection activities, what are the test activities, what are the maintenance activities, and what are the frequencies for those activities. Now, the different level of activity. At inspection activity, some of us have the ability to do an inspection activity. While we don't offer the traditional NFPA 25 inspection activity as a service, I would certainly hope that my personnel, if they were to walk into one of your buildings doing any type of survey, if they saw something wrong with the system, they would identify it for you. I was actually doing a fire alarm project in Manila in the Philippines several years ago. And every day as I walked to my contact's office, I saw sprinklers that were heavily loaded. So as I produced our documents, separate from the fire alarm report, I provided a letter to my contact saying, you have some loaded sprinklers. I provided photographs of it. And I said, you might want to evaluate the effectiveness of your inspection, test, and maintenance program because that should have been identified during an annual inspection of the system. That's not a design issue. That is a wear and tear, is the system in proper operating order. Now, testing is something that causes us to physically activate something. We're going to pull this pull station and and this pull station is going to actuate the fire alarm system. In a sprinkler system, we're going to flow water to see that the alarm system actuates. So we're doing a function to make sure that the system is in proper operating condition. Now, as much as I said, many of us can do an inspection activity, many of us are going to be limited as to what testing activities we will perform. If my insurance carrier were on this call, he would hope that I would tell you we don't do any test activity because it just poses some liability that as an engineering firm, we really should not be absorbing. And if I were to flow water in your system and a coupling failed, I don't have the ability to help you get that system back in service. I can help you through the impairment process to get the system shut down, but after that, you're going to need to bring a contractor in to get the system back in service. Where if you have a contractor there, they may be able to restore that system to proper operating condition more quickly. And maintenance now requires me to have more specific information about the device. Here we see somebody cleaning a smoke detector. So manufacturers will typically give us maintenance of the device, how it should be performed. NFPA 25 may give us maintenance activities, may tell us to do it in accordance with the manufacturer's instructions, but I'm doing some action to repair a damaged component or putting the component back in service. And again, now I need to know more than just generic information about the device. I need to know exactly what's required. So who can perform these tasks required by NFPA 25? Well, again, the answer is it depends. In some states, some of the ones I've identified on this slide, there is a state agency that's going to require the contractor to have a specific license to provide that service or to touch a water-based fire protection system. In other states, and I'll use Maryland as an example, when I was with the Maryland State Fire Marshal's Office, we didn't have any licensing requirements. Now, we eventually did get a sprinkler contractor license requirement. It wasn't a technical requirement. You didn't take a test. It did not prove any technical expertise, but it did register you with the state that you were a sprinkler contractor. It did make sure that you had certain insurance coverages and so forth. And from an enforcement standpoint, if I were to walk into a building and observe work performed by a sprinkler contractor, a licensed sprinkler contractor, and I didn't think that work was performed properly, then from an enforcement standpoint, I could take away their license. And if they continue to offer that service without a license, then that gives me some other enforcement activity, just like your license to operate a vehicle. If a police officer pulls you over for a violation and then determines that your license is expired or has been suspended, you will probably get a separate violation for operating without a proper license. All NFPA 25 says about who may provide inspection, test, and maintenance activities is that you have to be competent, you have to be capable of performing the task, you need to be trained in the task to be performed, and finally, it's up to the authority having jurisdiction, typically a fire marshal entity, as to whether you are qualified to do that. The way I would enforce that is if somebody was doing their own inspection, test, and maintenance, I would potentially ask to see a certain test to be performed. And if I asked for an inspector's test and they went and did a main drain test, then I would probably say that person isn't qualified to do the test because they don't understand the difference between those two tests that are required by NFPA 25. Overall, the owner or their designated representative is responsible for proper maintenance of any water-based fire protection systems. That is explicitly stated in NFPA 25. It's explicitly stated in fire codes. Attorneys love that statement. You know, when I do a construction defect case, it's not always clear who's responsible for the non-compliant condition. Was it the contractor, the design professional, a subcontractor? And all that gets settled through the litigation. But when it comes to inspection, test, and maintenance, people point to this paragraph, and everybody will go to the owner. Now, the owner may come back and say, oh, but I have a contractor, and that's fine. And then we'll look at the scope of that contractor. We'll see what services that contractor is providing. And then the contractor may become a defendant in the case also, should there be some failure of the system. Now, some other things that you are required to do as the owner. You are required to give the entity doing the inspection, test, and maintenance service access to the spaces they need to access. One of the contractors in that health club fire case in New Jersey argued that they were not given access to the spa or the sauna where the fire started because it was in the woman's locker room. They never noted that on the report. And again, we had a couple different contractors in there, so there were multiple parties involved. But the fact that they did not note that the owner failed to provide access to that space, again, the court found them to be negligent in providing the service. There really was, other than a verbal statement, no proof that the owner denied access to the space. So this is a coordination issue. As an owner and a contractor, you need to understand where the contractor needs to go and develop a plan to allow them to have access to the required spaces. If you have a reason to shut down your system, you are required to notify the authority having jurisdiction, the fire department who's responsible to respond to a fire at your location, and assuming your system is monitored by an alarm receiving facility, the alarm receiving facility. You'll tell them why the system shut down, and then you'll notify them when the system goes back in service. Many insurance carriers require you to put a tag on the system, an impairment tag. Again, telling me when it was impaired, when it was put back in service. When it's put back in service, the impairment tag should be removed, and you should do a valve test, which is typically a main drain test or some drain test, to verify that the valve is now back in the open position. But these notifications, again, generally are the responsibility of the owner. The owner is responsible for corrections and repairs. Now, I've had some owners in some lawsuits want to make an argument that, well, the contractor found the problem. Why didn't the contractor just immediately correct it? And if I'm representing the contractor in that case, my argument's going to be, so you're giving the contractor a blank check to do whatever they need to do. That's generally not the case. Now, on the other side, I've had contractors that haven't given proper notice to an owner of the deficiency, and a failure occurred between the time of their inspection and the contractor sending them notification, and there, in that instance, the contractor did assume responsibility for not giving proper notification of the need for the repair. But ultimately, the repair is the owner's responsibility. And I think I've probably already covered this slide adequately. You, the owner, are responsible for any changes that might affect the performance of the system, whether it's a construction change, a change in the way the space is being used, a change of occupancy classification, changing a process in a building, changing the materials that are being used in that building. So just verify that somebody is doing that analysis for you. There is a form in the annex of NFPA 25 it's a pretty general form. It can help you, guide you through the hazard evaluation. Personally, I think there's a little bit more to it than what's on the form, but there is a form for that purpose. And lastly, you as the owner are responsible to maintain the records. In some jurisdictions, you are required to send them to the authority having jurisdiction. In most cases, you just need to have them available upon request of the AHJ. With regard to inspection, test, and maintenance records, you are required to keep them 1 year after the next test. So anytime I walk into the building, I'm likely to be able to find, if it's an annual test requirement, I'm likely to be able to find 3 years worth of test information. And the reason for that is some of these tests are comparative tests. I want to see if the pressure is decreasing over a period of time, or the flow in the fire pump is decreasing over a period of time. Now, I bolded that third bullet because NFPA 25 also says that you are to maintain the original acceptance test records. So within NFPA 13, there are requirements for an above-ground piping certificate and an underground piping certificate. It includes information about the system and what tests were performed. The contractor is required to give that to you upon acceptance of the system. NFPA 25 says you should have that documentation. And again, that is useful documentation to determine what tests were done. So if I have a sprinkler leak in a coupling, was a hydrostatic test done upon acceptance of the system? Or what tests were done on an annual basis to verify that the system was in proper operating condition. Now, again, on the original acceptance test, I can compare that annual fire pump test to the pump performance when it was first installed in your building. And I can make sure that you don't have any overall degradation from that original acceptance of the fire pump. And that addresses the issue of very small decreases in performance every year. Now I can compare it to the original data as well. NFPA 25, more recent additions, the ones we're talking about, 2015, 2017, do define something called a critical deficiency and a non-critical deficiency in addition to impairment. There's a table in the annex that helps me identify what is critical, what can have an adverse effect on the performance of the system versus what is not critical. The original intent of these definitions was to provide a timeline for compliance. The 25 committee chose not to put in a timeline, thinking that that is really an issue for you to work out with the authority having jurisdiction. Yes, you may have a critical deficiency of your sprinkler system, but you may have some more significant deficiencies in your building that need to be addressed as a higher priority. So it does give me a way to potentially prioritize your plan for improvement. Okay, let's look at a couple things that are new to the 2020 edition of NFPA 25. Before I do that, I will mention, since my objective talks about things new in NFPA 13 as well, when you transition to the 2019 edition of NFPA 13, you're not going to find anything. For those of you familiar with the standard, and you know, like I said earlier, you go to Chapter 8 for the special situations, that's no longer in Chapter 8. And it's not just a matter that things moved around, chapters got renumbered. We really restructured a lot of the content within the various chapters. So water supply that used to be at the very end of the standard is one of the first chapters now, because if you don't have an adequate water supply, then I have a problem trying to provide sprinkler protection. So we talk about the water supply requirements up front in the standard. Relative to storage, everything used to be arranged by the type of storage. Was it bin box or shelf storage or palletized storage on racks? Now it's what type of sprinkler am I using to protect that storage? And you will then find all the different requirements associated for that sprinkler, whether it's shelf storage, bin box storage, or rack storage. With regard to NFPA 25, one of the things the committee has debated for several editions is what's the role of the inspection entity when it comes to recalled sprinklers. And we finally settled on some language that actually is in the owner's responsibility section in Chapter 4, but it does say if anybody discovers that there are sprinklers in a building that are subject to a recall or replacement program, the owner is to be notified in writing. So the way I might do this is I might, because sometimes I can't see it from the floor when I look at the sprinkler, I don't know well enough. But when I go look at your spare sprinkler cabinet and I look at those sprinkler identification numbers, again, I can do a search and I can determine if that sprinkler is subject to recall. And since you should have sprinklers in your spare sprinkler cabinet that are representative of the sprinklers in the building, that's probably the best way to do that. But the language doesn't quite say the contractor has to do what I just said. It says if the contractor happens to notice that you have recalled sprinklers. My son started at a new high school, and I went to his freshman year, I went to the back to school night, and I looked up at the sprinklers, and at the end of the night, I went over to the principal and I said, do you know you have recalled sprinklers in here? And he said, yes, we do. We're working on getting them replaced. But it's not always that simple. It's not always that easy to identify recalled sprinklers. So we're trying to help you out by saying, if anybody notices it, they should let you know as the owner in writing. One of the changes, and I think this will continue in subsequent editions of NFPA 25, is increased recognition of automated test equipment. We are often criticized, we being the 25 committee, for requiring you to flow so much water in water flow tests, main drain tests, backflow preventer tests, fire pump tests. And of course, in some instances, we've even had situations where even the state fire marshal might say, don't flow water because of a water shortage. That happened in California a number of years ago. So technology is advancing to the point that I can now get automated test equipment for certain components of my sprinkler system, one of which is a water flow alarm. So in the 2017 edition, we recognized that automated test water flow device, but we required it to flow water. A change in the 2020 edition will now say you can put in an automated test water flow device that does not require you to discharge water. But it does have to be able to verify that you have water in the pipe. One of the arguments we had in the past in the committee was, well, if you don't flow water, how do you know there's water in the pipe? You know, maybe we're just moving this switch and we're getting this signal that says we have water flow. We don't really know if there's water there to flow in the pipe. So one manufacturer has now developed a water flow switch where when I put it in test mode, it moves the paddle so that we close the set of contacts and I get the alarm signal. And then when I terminate the test, it measures how long it takes for the paddle to reseat itself. And that delay in reseating itself is what lets me know there's water in the pipe. If there's no water in the pipe, the paddle would go right back to its original position, its non-alarm position. So again, you're going to see increased recognition for automated test equipment. We're not quite there for fire pumps. You still have to flow 150% of the rated capacity of the pump, but I would hope that at some point in time, technology may get us there. The other thing we had considerable discussion on, some of you use concealed sprinklers. These are sprinklers that have a cap over them so that I don't actually see the sprinkler. I just see this circular cap up at the ceiling. A contractor came to us and said, I had no evidence of corrosion, but I happened to remove the cap from one of these concealed sprinklers, and I saw that the sprinkler was corroded. So we debated that issue, and we added an annex note to say, no, the cover plates, the caps do not have to be removed for the concealed sprinklers. I would not be surprised if the committee doesn't come back and revisit this and that we are entering into the 2023 cycle, because I am hearing increased incidents of people finding concealed sprinklers that are corroded. So if you have them and you have suspicion that the environment in any way might cause corrosion of the sprinkler, again, while not required by NFPA 25, you may want to investigate whether you have corrosion on those sprinklers. And then the last one I want to talk about is fire pump test. And while this is new to the 2020 edition, we actually also issued this change as what's called a tentative interim amendment. So we did go back and revise the 2011, 2014, and 2017 edition of NFPA 25 with a TIA. And what that says is if you cannot read volt and amp readings without opening up the controller door and taking those readings inside the controller, you do not have to take those readings. And the concern is arc flash and the hazard associated with arc flash, and the committee determined that that's a more significant hazard than having a fire pump that we know flow, we know pressure, but we don't know what the amps and volts are that it's operating. So if I can see it on the surface of the controller, I should be recording it. Otherwise, I don't have to. And again, we went into previous editions of the standard to say that you don't have to do it as well. I will caution you that TIAs are not automatic, accepted by the authority having jurisdiction. So, you may want to verify with your AHJ that you don't have to take those readings. And there's language on the NFPA 25 website that talks about the risk associated with the arc flash and why those readings should not have to be taken. So just in conclusion, and give a little time for questions, we do have a LinkedIn discussion group. We call it the Life Safety Code discussion group, but we actually answer fire safety, fire protection questions on that. But you can search for a Life Safety Code discussion group, and it's free to join. And yeah, we will monitor responses. If we think somebody's posting things that are inappropriate, I'll reach out to them. If they choose not to change, we can potentially kick them out. But there's not really. We do have to go through an approval process to approve you to be a member, but it's not like we check your qualifications or anything. We also have a frequently asked questions site on our website that you can go to and ask questions, and sometimes we'll post those on the LinkedIn discussion group so nobody knows where that question came from. And here's my contact information. I will send this file as a PDF to Billy so she can send it to you. You'll have my email address. Feel free to reach out to me if you have any questions related to NFPA 13 or 25 or maybe something else that you think I might be able to answer. And that then concludes the presentation portion of this program, and I'm open to questions. So, Billy, I'll turn it back to you.
Thank you, Bill. Your first question is, can fast response sprinkler heads be used in a remodel where the rest of the building is standard?
So the answer is most likely yes. And in fact, we did that when we moved into some new lease space. I had a contractor install fast response sprinklers in our space. The only limitation in NFPA 13 is that you cannot mix fast response and standard response sprinklers in the same compartment. If I did it throughout my suite, I was fine. I could do it within certain rooms of my suite. I would have been fine. But I could not go into maybe a conference room and say, well, I'm going to change these two sprinklers to fast response and leave these two as standard response. Good question.
Okay, next question. ITM is the responsibility of the owner. In a university setting, where do you think that ITM responsibility should reside? Facilities or public safety?
Sorry about that. So where do I think it should reside? Boy, that's a tough question for me to just answer with the information that's being given. I guess I would say, where does the expertise reside? So the expertise on some of these systems sometimes resides in the facility group, but I also know some campuses that have a pretty large fire safety group, and maybe that's a better group. In some cases, there's a distinct split between those that do design and those that deal with the operation of the facility. So the NFPA 25 answer is we don't really care as long as it's being done by qualified persons. And I think the facility has to decide what's the best entity within their institution to assign the responsibility to that entity.
Okay, thank you. Next question. Can you speak to any special ITM considerations on a CPVC sprinkler system? What was the acronym again? Can you speak to any special ITM consideration on a CPVC sprinkler system?
I guess I'm not picking up the acronym. Maybe if the person could resubmit the question with the acronym, or I'm just not hearing you right, Billy. I'm not sure, but maybe they could resubmit that. If they resubmit it, we don't have time. We'll get to it later after the program.
He wrote back plastic pipe.
Oh, CPVC. Okay. So no, there really aren't any special inspection requirements in NFPA 25. We generically talk about inspecting the pipe every year. But I will say that there are some problems that people have had with CPVC pipe that you should be aware of, and maybe want to look for those as you do the inspection. One of the problems is a chemical reaction that can occur between the CPVC pipe and materials that come in contact with that pipe. So one of the things I didn't touch on is the NFPA 13 says you're not to use a sprinkler system to support any other load in the building. NFPA 25 kind of carries that one step further to say other objects also should not touch the sprinkler pipe. And to the best of my knowledge, this is really related to CPVC, although the requirement's more generic, and that I can have two products. I can have a product touching a CPVC pipe, and what'll happen is I get this chemical reaction. It can also happen with through penetration fire stop systems. So you might look for some stress cracks where things have come in contact with the CPVC pipe. If you have antifreeze, and antifreeze is a whole nother concern, but if you have antifreeze in a system with CPVC pipe, you may want to carefully look for leaks of the system, because antifreeze, again, most manufacturers of CPVC pipe will tell you that you should not put antifreeze in those systems today. So we have a lot of existing systems with antifreeze in the sprinkler pipe, and we have had some incidents of leaks with that. The others are really more quality of installation. If they use too much, or they use the wrong means to secure the pipe, that can be a problem. But I would just say as part of the inspection of the pipe, just look for things that might indicate that you have a pending failure of the system.
Okay, thank you. Next question, do you recommend to have an impairment program in accordance with IFC?
So the question is, do I have an impairment program in accordance with the International Fire Code, IFC? NFPA 25 has requirements for an impairment program. The IFC has requirements for an impairment program. They are similar but not identical. The insurance carriers will typically evaluate your program for compliance with NFPA 25. The fire marshal will evaluate your program for compliance with NFPA 25 or the IFC, whichever is appropriate. I will say that the 2021 edition of the International Fire Code will say that impairment programs that comply with NFPA 25 are acceptable for compliance with the IFC. So there is a movement to rely on the NFPA 25 requirements.
Okay, thank you. Next question is, are you allowed to use CPVC in high-rise buildings?
So the answer is yes. There are restrictions on the use of CPVC pipe. In most cases, it cannot be exposed. You may find limitations on the hazard classification that I can use the CPVC to protect, but there's no limitation in an NFPA document that would limit CPVC pipe to other than high-rise buildings.
Okay, thank you. We have one final question here. Who should hold the contract for ITM?
So again, I can't really answer that question other than to say whoever is doing the work needs to be qualified. Just because you use an outside contractor doesn't mean it's always going to be done correctly. I have found some facilities, in particular healthcare facilities, but I could see that some of your campuses, you might have a similar concern that after our experience with COVID-19, that people are becoming a little bit more hesitant as to who they allow in some of their buildings. And in fact, during certain states, during the public health emergency, have prohibited outside contractors from coming into healthcare facilities, even to do required inspection, test, and maintenance activities. So the questions you have to answer is, do I have in-house capability, or can I obtain in-house capability? Do we have adequate resources? If not, then clearly you're going to want to go to a contractor. If you do, then maybe you look at in-house personnel as doing that work. There are some entities now that have come out with software programs so that you have some of the same benefit as the contractor might have in terms of producing these reports electronically as compared to needing to produce a whole bunch of handwritten reports. So it can be done by in-house personnel. It really is a decision of the facility as to whether they want to hire staff. So again, that might be a question of how big is your facility. A large facility, I'm a graduate at University of Maryland, that very well may justify having in-house personnel because of the number of systems that require inspection, test, and maintenance. I can probably keep a full-time person, maybe more than one full-time person, busy doing the inspection, test, and maintenance of the system. But a much smaller school, before I went to Maryland, I went to a small liberal arts school in Pennsylvania. That school probably could not justify a full-time equivalent doing water-based fire protection systems. So now the question is, can my plumber, can somebody else be properly trained and qualified to do it, or do I go to an outside entity? Again, that's a decision the facility would have to make.
Okay. Well, thank you so much, Bill. I want to thank you for taking time to do this presentation today. And I'd like to thank all the people who took time out of their busy schedules to be present for this. So until next time, be safe, stay healthy, have a great afternoon. Bye-bye now.
Thank you, Billy.
Thank you.